Hey, I'm Marc, and I hope you're all here for this talk. I could have called it Creating a Django-like Environment with Flask, but unfortunately I've been watching too many cooking shows, so they seem to like deconstructing things. So for this talk, I'm going to assume a basic familiarity with Flask, and I need to get something off my chest. I think Django's pretty awesome. But you know, the grass always looks greener on the other side, and this Flask thing tends to look interesting. Maybe some of you have looked at some of the tutorials and have got excited about them. The hello world is really pretty simple and makes it look very easy. But you've also thought, you know what, this is great, but what happens when I want to create a bigger application? And how do I scale up? So let's experiment and see what happens. As a developer, it's always important to limit our scope. So for the purpose of this talk, we're going to talk about an API-only application. That means no end-user API, no end-user UI, no HTML, no CSS. We're talking pure Python. I think this is a fairly fair limitation because with recent trends towards API first with JavaScript front ends, microservices, and mobile being a thing, I think the place for Python is in API only. And personally, I like API only type sites because CSS really isn't my thing. So a quick review. What is Django? It's a huge framework with lots of components. There's ORM, routing, templating, views, forms, models, migrations, configuration, tasks, tests, assets, authentication, sessions, messages, interalization, signals, caching. Clearly, there's a lot of choices that Django has made for you, which is great because it allows you to get started and get productive fast. And as long as you stay in bounds with the framework, life is pretty good. On the other hand, Flask is a library. It leaves you with lots of freedom to choose what you want to do and what you need to get done. But that means choices, decisions, and analysis paralysis. It's got lots of great primitives, and it leaves you to decide which parts you need, which parts you don't need, and how you want to assemble them. When you're getting started, that means you have dozens more decisions to make, more research to do, and finally, you have to decide what trade-offs make sense for your application. One goal of this talk is to provide a more Django-like, good enough experience and selection of tools for most applications. As we're talking about API only, we're going to ignore things like templating, forms, static assets, messages, and internationalization. So, what is a REST API anyway? It seems like we throw this term around a lot, and we don't always adhere to the true definition. I think there's been a few other talks already about this. Most people will agree that we're talking about HTTP, preferably HTTPS, with JSON payloads. We're also going to define our API in terms of resources and use HTTP verbs to manipulate them. And that corresponds to the Richardson Maturity Model Level 2. There's many purists who will insist on achieving Level 3, which includes adding hypermedia as the engine of application state, which essentially boils down to including navigation links to make your API more discoverable. But for this, we're going to be practical, and I don't think we need to go that far. So what should we build? I'm biased, but deploying to the cloud seems to be pretty popular these days. So let's build a simple autoscaler that will help us handle load spikes. That way, I won't get paged at 4 a.m. when somebody in the European Union wakes up, discovers there's a new press about your website, and there's a stampede. We're going to keep things really simple. The autoscaler is just going to pull a URL on your application. If the application returns a 200 OK, we're going to assume that nothing needs to happen. If it returns a 503, temporarily unavailable, that means the application is struggling and needs more resources. This allows the autoscaler to monitor several applications at once without needing to understand the internal metrics and conditions that are required for scaling those applications. It's a good fit for an API microservice because we don't have any real end users who are customers. We're just talking about other developers. And for the most part, it's set and forget. It solves a real problem because personally, I like to sleep. And hopefully, it's small enough that we can talk about it in 25 minutes, but big enough that it feels like a real project. So what's our API going to look like? We're going to define 3 endpoints, a generic list endpoint to get a list of all applications that a user has access to. We're going to define a more of a detail endpoint to get more information about a specific application. And then we're going to define a check, which is how we're going to configure which apps the autoscaler is going to monitor. The first two are going to be read-only, and the check we're going to be able to create and delete them. So, mentioned all the components that are part of Django, and one of the biggest, most important ones, I think, is the ORM, which defines how you access your data and what your models look like. In Flask, there's lots of options. For relational databases alone, there's SQL Alchemy, Peewee, Pony. You can build your own, or you can just use raw SQL. One big advantage of not having an ORM built into the framework is that you're free to go for more stoic options. You don't have to use a relational store. You can get into Mongo or ClearDB or something different, if that's a better fit for your particular application. As we're trying to create a Django-like experience, we're going to go with SQL Alchemy. It's probably the most mature, well-established of all the options. It's full-featured and has plenty of support. The other relational options are interesting as well, but one thing that I like about Django is it provides a nice, stable, and consistent platform. So I've got a couple examples of what a model will look like using Flask and SQL Alchemy. They should look pretty familiar, though with maybe a little less syntactic sugar than we're used to. For instance, there isn't an email field type provided. We're left to define the validation ourselves. And this is a theme that we see again and again. The building blocks are all there, but it needs a little bit of effort to get the polish. Likewise, we have to set up the relational table manually for all our many-to-many relationships. Again, this isn't a big thing that we have to do or hard, but it's another step, and where Django would do it automatically for us in the background. Migrations are closely tied to your ORM. And so for the most part, this package picks itself. We're going to use Flask Migrate, which uses Amalek under the hood. And again, it's pretty familiar to what we're used to with Django. There's two commands that we're going to be using most of the time. db migrate to create migrations, and db upgrade to actually run them. So, as I said before, it looks pretty familiar. Probably familiar enough that you can figure out what's going on, but they are different enough that you are going to take some effort to learn them. Some notable differences. By default, changing a column type isn't going to be automatically generated. There's absolutely no support for renaming a column automatically, and there's no frozen or historical models. So you're going to be working with basic SQL when you're doing your migrations. Again, you're forced to do a little bit more work than you would have to do in Django. And in this particular case, unless you have a fundamental problem with how Django migrations work, Flask isn't really offering much for us. When it comes to how you organize your app, it can have a big impact on how quickly new contributors can get up to speed. Django has a fairly well-defined structure that everyone understands. Flask lets you do pretty much anything you want. For our excuse me. For application, we'll follow the Django pattern as closely as possible because we're already familiar with it, and the Flask community itself makes similar recommendations. Flask doesn't have the same concepts of composable apps that Django does. Thank you very much. Flask doesn't have the same concept of composable apps that we are familiar with from Django, but it does have blueprints, which act as a very lightweight application. It gives you an ability to define module-level routes and URL definitions. When it comes to configuration, you're going to be free to use a 12-factor approach, or more familiar to some settings, a separate settings file per environment. So for this application, you can see there's three sort of apps. We have Scaler, which is the core business logic around monitoring and scaling. We have API v2, which is going to be the REST API. And we have utils, the ever popular dumping ground of useful bits that don't fit anywhere else. We also have at the top level our settings file, a management command file, our main application stored in Dino Up, and web app, which is basically our WSGI application. When it comes to authentication and sessions, in some ways, I cheated a little bit here and used an OAuth bouncer middleware. But again, I feel this is a fair decision to make. For microservices, we don't want to manage identity in every single application. And in this case, we also need to capture a user's OAuth token so that we can later use it to help scale. The middleware itself does the OAuth dance and then ensures that a valid authentication token is required for every request that a user makes. If I were to do in-app authentication, I'd have used Flask Security, which takes a more Django-like approach to things. It combines a number of other Flask and basic libraries into a more turnkey solution for authentication. It takes care of integrating Flask Mail, Flask Principal, Flask Script, Flask WTF, and it's dangerous for you. And it provides a good example of how it's possible to take the building blocks that Flask provides you and create a better developer experience. Adding the middleware itself is pretty straightforward. We just replace the standard WSGI application with our OAuth bouncer. The other interesting thing we have to do is when we get the OAuth callback, because the user completed the OAuth flow, we're going to capture their token and store it onto a user model. The admin interface itself isn't usually too exciting. It's a feature that some people love about Django and some people don't. And some argue that it's better to have your own single-page JavaScript admin to provide a better user experience. Regardless, I think, especially in the early stages of development, it's useful to have an admin to allow you to inspect what data you have in your application. It's very similar to the Django admin, and you can easily do the basics of controlling what gets displayed, what fields get searched, and what can be modified. Alongside the admin interface, management commands are an important interface for your application. This is one area where there aren't a lot of options with Flask. Flask script is going to be your go-to library. Here's a sample command that we created. There's some things to note. There's no automatic detection of commands. You're going to have to explicitly register them with your management command each time. Option processing can still be a little bit awkward and could use some polish. And once again, we see that even though the Flask gives you all these choices, the cost is you have to do a little bit more legwork. So we've got the preliminaries are out of the way. The real core of the application is going to be the API. So before we talk about how we do an API, what do you expect from an API? Do you want it to deal with schema definitions with something like Swagger or Blueprint or JSON hyperschema? Do you want to have a middleware to validate requests and responses against the schema? Should it have an interactive browsable API, something like what Django REST framework provides? I think those are all nice things to have, but they're not absolutely necessary and are often ignored. At its core, it needs to do JSON serialization, error handling, and I think I'd prefer to have class-based resource handling rather than having a whole bunch of functions scattered around. So what are some of the options that we have? Flask API looks very promising, and it creates a DRF-style browsable API, but I think it's maybe a little bit too early to endorse that. Flask RESTful would seem like a clear winner, but some of you may have already noticed that we're on API version 2 already in this demo app. And that's because originally I tried Flask RESTful, but I found it was too easy to make poor API decisions, and I firmly believe that the path of least resistance in the library should promote good decisions. So after experimenting with that, I think the best option is to use native class-based views in Flask, plus using the Marshmallow serialization libraries. One thing I'll point out is when you use Marshmallow, you need first the core library, you need Marshmallow SQL Alchemy, and you need Flask Marshmallow in order to get everything working. That means the documentation is split across 3 different packages, and you have to go to 3 different places when you're looking for the right option. So until you're familiar with them, it's often hard to know where the right place to look. So here we have an example of a Marshmallow schema. And it's pretty similar to the idea of Django REST framework serializers. It handles converting Python data to JSON and vice versa. We simply have to define which model we're going to tie the schema to, and then we can override the defaults to limit the fields that are going to be serialized and make them read-only if necessary. There's also more options for customization if you want to go down that route. You can define methods that return values if you need to. So the next thing we're going to deal with is error handling. We're going to define some custom exceptions. In this case, we have a basic 404 not found error. And one nice feature of Flask is that it allows you to define your error handlers separate from the views. So this gives us a nice, easy way to have consistent error responses. We don't end up with accidentally putting an HTML response out. It also means we don't have to pollute our code with our views with extra code to deal with errors. So, onto an actual meat of the view. This is clearly for a check resource. We're going to follow a familiar Django pattern of having sort of get object type methods to do some of the work of finding what we're talking about. You can see we've used our custom not found error for when maybe the user put in a URL with an app ID that doesn't exist or a check that doesn't exist. In this case, we're also using the upstream service as a lazy way to do a permissions check. This is probably not a great pattern to follow, but I think for this application it's okay. The last method in here is our serialization method that uses the Marshmallow schema to create a JSON response. So when we put that all together to create our actual handlers, I don't think couldn't be much simpler. We simply recover the check based on the app ID and the dyno type, and then we return our JSON response. The put is also very similar. We do our cheap permissions check. We use Marshmallow schema to validate the request, and then we use the mediator or interactor pattern so that we're keeping business logic out of the view and allow the view to focus on the API side of things and not the business logic. Now we've got our view class. We just need to wire it up to the route. There are two ways of defining routes. The first is similar to Django's class-based views. We instantiate a view and register it. Alternatively, you can just use a decorator to make any function into a view. And for the simple case of getting apps, that's what I did. One thing I've not covered is throttling requests, but that's fairly easy to add as a view decorator. One of the last pieces we're going to need for this application is a way to handle background jobs. And this is not going to differ too much from what we're familiar with Django, because in large part, the background job frameworks are a beast of their own. You have many of the same options: Celery, RQ, HotQ, Retask, or even gEvent. Unless you get into some of the more advanced features of Celery, tasks are going to end up looking much the same regardless of which framework you choose. And I'm picking Celery basically because I think it's more popular and familiar to most people. And that's going to help as other people adopting your application. So Flask provides a basic HTTP test library, but that's about it. On the other hand, most of the tools that you're already familiar with and using with Django are going to continue to work. Things like Factory Boy, Nose, Py.test, Mock, Betamax. Unlike Django, because there's no AutoDB setup, unlike Django, you're going to need to build out your own base case. And that is because Flask makes no assumptions about what your system's going to look like. For us, that means we have to set up the database each time ourselves. And if we wanted to be clever about using nested transactions, we're going to have to do it ourselves. Somebody hasn't already thought about it and done it for us. In this case, we've also had to fake out the bouncer middleware that handles our authentication, because obviously in our tests we're not as worried about it, or we don't want to be hitting an upstream service. And I've also used the responses library to mock out the responses that we expect from that remote service, which basically goes and monkey patches the request library to return no values from a file. So there are a few more packages that you might find useful for filling in the gaps. And from their names, you can probably guess what they're doing. I'm just including them if you want to look at the slides later. So to wrap up, what did we learn in this experiment? Django is all about the ecosystem. Don't underestimate the power of the ecosystem. It's because it gives you a lot more. There's usually a lot more documentation available and support. There are packages for many high-level application features, things like timelines, autocomplete, badges, commenting, even full e-commerce applications. One downside is you can end up stuck with some of the choices that Django makes. On the other hand, Flask is about control. It's a hands-off approach that means you have the freedom to optimize for whatever your needs are. It's often harder to create higher-level, polished packages because there's less assumptions that have been made already. Finally, if you choose Flask, you're making an investment that's going to take time to pay off. If you want to look at the code, it's available on GitHub as the slides. You can get hold of me on email or Twitter. And I think there's a little bit of time left that we can take questions, but thank you for listening.